Hello, this is Dr. Matecki back with the first part of Chapter 5 on inflation, causes, effects, and social costs from Gregory Mankiw's Macroeconomics. As usual, I'm going to be breaking down some of the key points and going over some of the math to make this a little bit easier to understand, hopefully. There's a lot of stuff in this chapter that you can just read on your own, and I'm not going to rehash that. Instead, we'll spend our time going over the quantity theory of money, money demand, and then finish up by talking about the classical dichotomy. In order to talk about the quantity theory of money, we first need to have a good understanding of what velocity is. So this might be a new term for you. So the basic idea is that this is how many times a typical dollar is spent, the rate at which money circulates. So for instance, let's say in the economy we have $500 billion worth of transactions, and we have $100 billion worth of money that can be used to facilitate those transactions. Well, the simple math suggests that, well, if we're gonna carry out $500 billion worth of transactions and only have $100 billion worth of money, each of those units of money needs to be used 5 times or spent 5 times to allow all of those transactions to take place. So in other words, the velocity for this simple circumstance would be 5. So turning that logic into a mathematical expression, what we did before was took the $500 billion worth of transactions, divided it by the $100 billion worth of money. And so essentially what we can say is that velocity is equal to the dollar value of transactions, T, divided by the money supply. Now, tracking the total dollar value of transactions isn't something that we normally focus on. We usually focus on GDP, remember, which is just the sale of final goods and services. If we counted all total transactions, we'd be looking at purchases of used goods, purchases of intermediate goods, lots of things that isn't counted in GDP. So as a proxy, as a stand-in for the dollar value of all transactions, we are going to use the dollar value of GDP, in other words, nominal GDP. So if we substitute nominal GDP, which is real GDP, this is the quantity of goods and services, we multiply it by the average price of all goods, we get the dollar value of GDP, or nominal GDP. So P times Y is just equal to what we call nominal GDP. So if we substitute P times Y in for T as a proxy, we get the expression velocity is equal to nominal GDP divided by the money supply M. If we just do a little bit of rearranging using some algebra, if we multiply both sides of the equation on the previous slide by V, we get what we call the quantity equation. M times V is equal to P times Y. This is what we'd call an identity. It's basic accounting. It's by the definition of the variables, this must be true. So in order to satisfy this dollar amount of transactions, given some amount of money, we need to spend that money over and over again in order to satisfy all of those transactions. This part of the text was a small departure from the main topic here. But money demand is going to be a theme that we see over and over again in the text. So this is a logical place to sort of start talking about it. In the rest of the chapter, we're going to talk about a little bit more sophisticated definition of or formulation for money demand. But here we're going to talk about it in simplest terms. So we need to talk about, when we're talking about the demand for money, we need to talk about real money balances, M divided by P. So remember, this real means we're sort of correcting for the impact of prices. So dividing by the price level P gives us the purchasing power of money. So in other words, think of it this way. If you have a ton of money, you might think, oh, this is great. We can buy lots of stuff. But what if prices are really, really high? So how much stuff the amount of money you have can purchase depends on the price level. So if we're going to make some decision about how much money we want to hold, really we should focus on the amount of real money balances we want to hold, because that's what matters for our decision making, right? So we need to factor in both how much money we want and the prices of the things we need to purchase. So a simple formulation for money demand looks like this. So this M over P is real money balances. This little d means demand. So the demand for real money balances is equal to K times Y. So remember, Y we think of as real GDP, but simultaneously it's a measure of income as well. So in this context, think of this y as income. So what this says is that our demand for real money balances is based on our income. It's a function of our income, and we want to hold a fraction k of our income as money available for purchases. So k might be something like 0.2, and in that case, that would imply that we want to hold 20% of our income as money, keep it liquid for purchases. So k is just some exogenous, it's just some number that's determined elsewhere that we're assuming. So we're not trying to explain what determines k, we're just using k, taking it as given. To see the connection between these two things, we just need to do a little bit of algebra here. So if we take the quantity equation mv equals p times y, so we can just say, all right, let's divide both sides by p to get an equivalent expression. And now we have something that looks like money demand, m over p, is equal to y over v. So I just divided both sides by p first and then divided both sides by v. So we're just rearranging this. And so this is the same thing as saying m over p is equal to 1 over v times y. And so now if we compare this expression here to our money demand, we can see that 1 over v is equivalent to k. And that's where this connection that the textbook talks about comes from. So intuitively, what this means is that if k is large, that means that people want to hold a large fraction of their income as money. So if everyone's holding lots of money, then it doesn't have to be spent as often to satisfy all the transactions, right? So we're holding a lot of our income as money. We don't need to spend it as often. So velocity is small. If k is small, we're not holding very much money, then it needs to be spent over and over and over again in order to satisfy all the transactions. So there's this inverse relationship between k in the money demand equation and v, velocity. The quantity equation alone doesn't give us a whole lot of useful insight because it doesn't allow us to pinpoint causality, what is causing something else to change. So we need to add a little bit of the theory we've developed so far and then also talk about the nature of velocity. So once we start making some assumptions about the variables in the quantity equation, it then becomes the quantity theory of money that allows us to draw some conclusions. So one of the big assumptions here is that our velocity, we're going to assume that it's constant and exogenous. In other words, the interaction of mv, p, and y does not determine velocity. It's determined by some other process outside of this model. So if we assume that it's constant, it's just fixed at some number v bar. Now, if you were to look at a time series graph of velocity, it's not constant. So in and of itself, that doesn't seem to be a super great assumption to make. But the fact that it's exogenous, it's determined outside the system, really allows us to, even if it's not constant, as long as it's exogenous, it allows us to develop some intuition, even if the quantitative predictions aren't exactly perfect. So the quantity theory of money is a theory of the price level. It's a theory of how the price level is determined. So let's talk about the assumptions we've made, the nature of these variables, and the sort of order in which these things happen logically. So if velocity is constant, remember we're assuming v is constant at v bar, then the right-hand side of the equation is the only thing that's going to be changing is m. So in other words, any change in p times y, or we can even say the overall value of p times y, nominal GDP, is determined by the money supply m, right? So if m goes up, we know that the right-hand side has to go up. If m goes down, we know the right-hand side goes down. We can further make some sense of this GDP variable. So remember, where is GDP determined? Well, we talked about that in chapter 3. Real GDP, the supply of real GDP, is determined by the factors of production. So capital, labor, technology, it's determined outside of the model. The one thing that is not caused by, or that does not affect the production side of real GDP is the money supply. So M does not determine real GDP. So if y is determined outside of the system, v is constant, there's only one other thing that can change if m changes, and that's the price level. So if m goes up, we know that p is going to go up. If m goes down, then p is going to go down. So there's this link between the price level and the money supply. So again, with v constant, the money supply determines the right-hand side, nominal GDP. Real GDP is determined outside of the system by the factors of production and the production function, technology. And then finally, the price level is defined as the nominal ratio of nominal GDP to real GDP. So remember in chapter 2 we talked about the GDP deflator. You talked about that in principles of macro also. So a measure of the price level is the ratio of nominal GDP to real GDP. To get some further intuition out of this quantity equation, it's helpful to convert it to growth rates. So don't let this notation fool you. So when you see this delta m over m here, this is just like your standard percent change formula. So you may have seen something like new minus old over old to calculate percent change. So this is just the change in m divided by the original value of m. So this is the percent change in the money supply, the percent change in velocity, the percent change in the price level, the percent change in real GDP. So if it helps you to sort of change this notation a little bit, so delta m over m, you could actually just rewrite this as the percentage change in m. So a little percent sign delta m, if that makes more sense. And so, again, remember the quantity theory assumes that velocity is constant. So if velocity is constant, then the percent change in velocity is going to be 0. So this term right here, this delta v over v, is just going to go away. It's equal to 0. So just some sort of intuitive interpretations of these terms here. So remember, the change in the price level, percent change in the price level is what we call inflation. So this is inflation. Percent change in real GDP is the growth rate of real GDP. And the percent change in the money supply is just the growth rate of money. So in macro models, we use the Greek letter pi to stand for inflation. So pi is equal to the percent change in the price level. So if we just do a little bit of rearranging and solve for this term here, so in other words, subtract delta y over y from both sides, and then we get this expression here. Inflation is the difference between the growth rate of the money supply and the growth rate of real GDP. So another way to think about this is that, what is the source of inflation? Well, if the growth rate of money is really, really high relative to the growth rate of GDP, then we're going to see inflation. So we need a certain amount of money growth to facilitate new transactions. If real GDP is growing, that means we have more goods and services being produced and exchanged, and so it makes sense that we need additional money to facilitate those transactions. Otherwise, it's going to cause prices to change. But if all of a sudden we start printing lots and lots of money, right, that's when we're going to see high inflation. And in fact, episodes of hyperinflation, when we see extreme inflation, it's almost always caused by really, really high rates of money growth. So the government can essentially print money in conjunction with the central bank to fund expenditure, to pay off debts, and that sort of thing. And so so the experience of many countries when they sort of depend on using the money supply to fund their operations, that's going to lead to very high inflation. One of the key takeaways from this relationship that we just developed here between money growth and GDP growth and inflation is that this implies there's going to be a one-for-one relationship between changes in money growth and changes in the inflation rate. So in other words, since y is determined outside of the system, if money changes, that's not going to change this y term here. So if money changes, if money growth increases, then the only thing that can change is inflation. So if money growth goes up by 1 percentage point, then inflation should go up by 1 percentage point as well. If money growth goes down by 2 percentage points, then inflation should go down by 2 percentage points. And so as always, if we have a theory, we should confront it with the data to see if it makes sense. And I highly recommend looking at all the different graphs in the textbook. I'm not going to go through all of them, But the lesson is clear that that countries with higher money growth rates definitely exhibit higher inflation rates on average, especially in the long run. So in the short run, all sorts of things can affect the price level and inflation. But the long run trend is what you should focus on. If you have an economy that tends to produce money at high rates, then you're going to see higher growth in prices as well. And so I'm not going to talk about all the graphs, but this one I think is particularly interesting. So this looks at the US data from 1960 to 2019. The green line is M2, so this is a measure of the money supply. Core PCE, this is a measure of inflation. CPI is another measure of inflation. So core PCE tends to be a little bit less volatile than the consumer price index. So you can see that. So they're very highly correlated. The blue and the red lines follow almost in lockstep, but the red line, the fluctuations just aren't quite as severe. And so the PCE way of measuring prices is the preferred measurement for the Federal Reserve when they're making policy. So one thing to notice here is that when we have M2 growth over here, so if you drop straight down, you see that the price level isn't rising so much, but what happens is it starts to rise eventually. And so you see the growth of money impacting the price level with a lag. So again, here the money supply is increasing right here. At the same time, the price level is actually decreasing, but when this is happening, we should expect that eventually prices are going to go up. And sure enough, what do we see? The price level goes up a short time after, and so you see this sort of lagged effect throughout this time series. A couple other things to note. So remember the 1970s, we called this period the Great Inflation, and so we see that the price level definitely was higher inflation was definitely higher than the rest of it, and the money growth is higher as well. And so you also notice that after the early 1980s, we sort of see this sort of low and stable inflation for much of the time period. And so again, this is a reflection of the Federal Reserve getting a much better handle on sort of policy. And these spikes in the money supply are intentional to fight the inflations that were happening, or the recessions that were happening at this time. So around 2000, right, we had a recession. So the Fed is stimulating monetary policy. They're putting more money into the system, liquidity, to try and stimulate the economy. Same thing here, 2008, 2009, right? So money supply growing to sort of fight that financial crisis. If we zoom into the last 20 years, we get some interesting things as well. So again, this is U.S. inflation and money growth, same variables. So one thing you notice is that there's an awful lot of increase in the stock of money in this time period, but it never actually led to inflation. And so this was this sort of long run situation we found ourselves in. The Fed was stimulating, and we just never sort of hit our stride in terms of economic growth, and so prices never tended to rise, and so we were sort of stuck in this low inflation environment, actually lower than what the Fed had wanted in this time period here. So you can see that we're very close to deflation. And then the other thing to notice here is that this huge increase in the money supply. So this is an example of the Federal Reserve using policy to counteract the impact of an economic downturn. So this is COVID. The economy shuts down, and so the Federal Reserve is printing lots of money to try and stimulate economic activity. So a thing to watch for, right, going forward, you'd suspect with all this money growth, we'd have to be concerned about inflation down the road. And sure enough, we're experiencing high inflation right now. The Fischer equation, and a related phenomenon we call the Fischer effect, is very similar in logic to the quantity theory of money. So the Fischer equation just says that the nominal interest rate I, so remember the nominal interest rate is not corrected for inflation. This is just the interest rates that we see advertised at banks and online and that sort of thing. So the nominal interest rate I is equal to the real interest rate plus the rate of inflation, right? So remember, this is a similar situation to real GDP being determined outside of the model. The real interest rate is not determined by the stock of money or anything that has to do with prices. Remember, the real interest rate is determined by supply and demand in the loanable funds market. So it's the interest rate that equilibrates savings and investment. You can also talk about returns to capital and that sort of thing with other types of interest rates. But the bottom line is that the real interest rate is determined by real factors. The nominal interest rate is determined by both the real interest rate and the rate of inflation. So if money growth does not impact R, you end up with the same sort of one-to-one relationship between inflation and the nominal interest rate. Inflation goes up by 1 percentage point, we would expect the nominal interest rate to go up by 1 percentage point as well. Inflation goes down by 2 percentage points, nominal interest rate should go down by 2 percentage points as well. So again, this is in the long run, so it does take some time to adjust, but ultimately that's the impact that we would expect to see, is that if inflation is high, then nominal interest rates will be high as well. So again, I think it's really important that you go through the slides and try these now. You try applying the theories question, so it gives you the question, and on the next slide it gives you the answer. So try to work through the problem and then look at the answer on the next slide. Just how to approach these sorts of problems. So this is this is a common type of problem you'll see in this chapter. So it says that velocity is constant. So this is our quantity theory of money assumption here. M is growing at 5% per year. GDP is growing at 2% per year, and the real interest rate is 4. So it asks you to solve for I. So remember, what is I? Well, I is equal to the real interest rate plus inflation. So I is equal to R plus pi. So if we're going to solve for I, we need two things. We need R and we need pi. So R is given in the problem, so this is 4. So the only other thing we need is the rate of inflation. So if we're going to find the rate of inflation, right, what is the other relationship we need? Well, remember, what is inflation? So this is delta M over M minus delta Y over Y. It's the difference between the growth rate in the money supply and the growth rate of real GDP. So again, in the problem, M is growing at 5%, so this term here is just 5, we know that. Y is growing at 2%, so this term here is 2, so the difference between 5 and 2 is simply 3. So pretty straightforward. Inflation is going to be 3%. We can plug that in here. So 4 plus 3, the nominal interest rate should be 7%. So if the Fed increases the money growth rate by 2 percentage points per year, so what happens to the nominal interest rate? Well, money growth, right, factors in here. So if this goes up by 2 percentage points, it does not change real GDP. So inflation is going to go up by 2 percentage points. That's going to filter into here. That's going to go up by 2 percentage points. And so the nominal interest rate should go up by 2 percentage points as well. That's that one-to-one relationship. GDP growth rate falls by 1% per year. That's going to increase the gap between these two things. It's going to increase inflation, right? So we have fewer goods and services being transacted, so we don't need as much money. So if you have more money chasing the same amount of money chasing fewer goods and services, we'd expect the prices to be bid up. So that's kind of the way you think about it. So if you have lots and lots of money chasing a few goods, you're going to have high prices. If you have a little bit of money chasing lots and lots of goods and services, then you're going to have much lower prices. So if the Fed wants to keep inflation constant, they're going to have to make an adjustment to match this change in GDP growth. So if GDP growth slows, then the growth rate of money should slow by the same amount. And I just wanted to flash this up on the screen. Here's the answer, so you can pause on this part of the video. I'm not going to go through this because I just went through it on the last page, but feel free to pause this and look at the answers if you need it. And that wraps up the Chapter 5 Part 1 video. Be back with Part 2.